So you are starting EQ number 21 today, and this is about polyatomic ions. So I just real quick wanted to talk about polyatomic versus monatomic, since you already learned about monatomic. Even if we didn't use that word, we still talked about them. You just may not know that that's what they were called. So before we talk about the EQ, I am going to go ahead and talk about polyatomic versus monatomic. I'm grabbing a marker. I don't know if you can see it. Is it going to zoom in? Notice, this is I'm really bad at this. A non-toxic blue marker, just for those of you that care. Non-toxic blue marker. All right, so remember we talked about the only kind of ionic bonding we've talked about so far was called monatomic. All right, and this is just a vocabulary clarification. Some classes I think I talked about it, some classes I didn't. So monatomic, we know mono means one, and obviously atomic refers to atom. Okay, so when we're talking about monatomic ions, we are specifically saying that we are putting an ion containing only one element together with another one. Okay, so monatomic ions would be stuff like potassium. Notice it's just K, nothing else. Something like fluorine, just F, no other element. Just oxygen, just magnesium. Okay, those are monatomic, one atom ions. What we're talking about today are called polyatomic ions. Okay, and we know poly, hopefully you know, poly is many, and then clearly atomic is still going to be for atoms. So many atoms. So some examples of polyatomic ions, which you're going to learn. Again, you're going to have a chart. You actually should already have the chart in front of you, and you can see these are all combinations of more than one atom or element. So something like polyatomic would be, this is nitrate, NO3 with a -1 charge. Notice it's nitrogen and oxygen all in one ion. It's still one ion, and it still only has one charge, but it's more than one element. Okay, something like NH4 with a +1 charge. More than one atom. It's still an ion, but it's polyatomic. I just want to clarify the vocabulary between the two. So when you see monatomic versus polyatomic, polyatomic has more than one element or more than one atom in it. Monatomic all only have one atom in them. All right, so moving on. You should have already copied EQ 21. It was up on the do now, but knowing most of you, you're copying it right now because you didn't pay attention while it was up on the do now. But remember, they're always up there. That's probably when you should copy them. All right, so your EQ says, are polyatomic ions ever broken apart? When are parentheses used in writing compounds using polyatomic ions? I doubt you can answer any of this right now, but by the end of this, you should be able to. And just so you all know, I'm still trying to up my meme game. So I have a meme. This meme actually only applies to honors because it says, obviously, you should not pass. If you haven't seen Lord of the Rings, wow, that's unfortunate for you. You should watch it. But it says you shall not pass if you do not memorize polyatomic ions. Only the honors classes are responsible for memorizing polyatomic ions. But some of them, you don't have to memorize all of them. If I were there, you'd be memorizing all of them, but I'm trying to be a little more lenient in my absence. Cyborg Miss Fiero is much nicer than regular Miss Fiero. But honors has to memorize them. Regular, you don't, but this is, I always say this as a disclaimer. You do not have to memorize them, but any of you who at this moment think that you want to go into the medical field or the science field, you are going to have to take chemistry, and you are going to have to memorize them at some point. So you're going to watch the whole lecture regardless. I'm going to show you how to memorize some of them. I have a much easier way than just trying to commit them to memory. But regular, you don't have to memorize them, but what I'm telling you is it might be a very good idea to figure out how to memorize them for when you get to college, because these will come back A teacher is not going to show you a super fun way to memorize them like I'm about to. So I would pay attention if you think you want to go into the medical field or science field, definitely pay attention. All right, let's get this show on the road. All right, so just like we talked about, in a poly, just, a couple seconds ago, not really because I'm not there, but just like I showed you a couple seconds ago, in a polyatomic ion, 2 or more atoms are bonded together. All right, so notice nitrate is a good example. Remember, when we have just a minus, it's like there's a 1 there. We just don't write it. You certainly can write the 1 if you want to. I'm going to zoom in a little bit. All right, I will definitely try to adjust this so you can see all the words. If not, I'll move it back, don't worry. So notice nitrate, it's got 1 nitrogen and 3 oxygen. Remember, the little number on the bottom is how many there are. And then overall, it's got a -1 charge. So a couple of rules. You never, ever, ever want to move the small number. Okay, the small little, or subscript, the number on the bottom. Okay, never, ever move that. So here it says don't move the 3. Nitrate, okay, is NO3. It can never be anything different than NO3. This is not a number you will ever cross over. It stays with the nitrate, NO3. All 3 of those travel as a pack. You cannot change that. Right? You know from previous naming that you can cross over the charge, which is exactly what we're going to do, but the 3 stays with the nitrate. Don't move it. All right, so notice the next bullet says sorry, this being crooked must be bothering almost all of you, but I'm trying my best to keep it straight. Only cross the charges, which is no different than what we've been doing, okay? No different than the naming you learned before Christmas. So in this case, the -1 is our charge. That's the number that you cross over to tell you how many you need of the other ion, right? And then like it says, when balancing in an ionic compound, okay, so when you're crossing the charges over, the polyatomic ion acts as a single unit of charge, which means this N and these 3 oxygens can never be broken apart. Do not break them apart. Right, so you treat them as a whole. So if you guys need to pause it, if you're still writing, just go ahead and have the sub pause it. If not, I'm going to keep going. So forget this. It's not your due now. Apparently it was at some point for one of my classes. It's not yours. So it says continue copying. Oh gosh, obviously continue copying the notes. Cyborg Miss Fiero is not paying attention. I would not make it through natural selection at this moment in time. All right, so as this says, which is the part you should be paying attention to, crossing over still works. You still cross over in polyatomic ions, okay, when using polyatomic ions. You're still making an ionic compound. It's no different than what we learned before Christmas. It's just the ion's a little bigger now, okay? That's it. That's the only difference. All right, so it says if we want to make magnesium hypochlorite, so for all of you, whether this is honors or regular, you all should have gotten one of these charts, okay? This is honors, and regular, obviously yours is a little bit longer because you guys don't have to memorize. But hypochlorite is on both of them because it's not one I'm requiring you to memorize in my absence. Normally you would, but I'm not going to make you memorize it because I'm not there, and it's a lot harder to kind of go through this without me being there every step of the way to help you. So hypochlorite is one I'm just going to give you. So notice hypochlorite, it's right here. It is ClO, okay, so 1 chlorine, 1 oxygen, and it's got a -1 charge. Okay, ClO, 1 chlorine, 1 oxygen, -1 charge. So that's what we have right here, right? ClO -1. And we want to make magnesium hypochlorite. Well, you guys all already know everything you should know about magnesium. We know it's Mg. We know it forms a +2 charge. Okay, again, crossing over, no different. Okay, do the same thing. The 2, remember, ignore the actual sign of the, positive or negative. The 2 tells you how many hypochlorites you need. So you need 2 hypochlorites. And then obviously the 1 is telling you that you need 1 magnesium, which is what is right here. Cross your charges, the same thing I just wrote. You end up with 1 magnesium and 2 hypochlorites, 2 ClOs. Now notice, I am never once referring to this as chlorine and oxygen separately. It is ClO or hypochlorite. Keep them together, just like we had on the last slide. All right, treat them as a single unit. Never break them apart. That chlorine and that oxygen are together. You cannot break them apart. They must stay together. So Cl and O, keep them together. All right, so the 1 applies to the magnesium, the 2 applies to the hypochlorite. One last thing you have to do, which this is the new step compared to the stuff we've been doing. We haven't needed parentheses up until this point, but now we do. So realize if we were to write this just the way it is up here, all right, sorry, I'm gonna move this up so you can see it. If we were to write MgClO2, all right, we know that looks like it's saying we have 1 magnesium, 1 chlorine, and 2 oxygen. And if I were there, I would say, hey, what's the problem with that? And all of you, well, not all of you, most of you would just kind of give me that look like, I don't know. And then maybe a couple of you might catch on and say, well, if this travels as a pack, okay, as a single unit, that 2 just can't just apply to the oxygen. It has to apply to the entire polyatomic ion. All right, it's not that we have 1 chlorine and 2 oxygen now. It's that we have 2 ClO ions, okay? 2 of these, they have to travel together. Think of them as an element now, okay? Think of them as a single element. You have to treat them like that. So we put parentheses around the polyatomic ion when we end up with more than 1 of them. In this case, we ended up with 2 of them, which is why it's written, okay, I'm going to rewrite it over here, as Mg parentheses ClO. Close your parentheses and put the 2 on the outside. Okay, just like in math now, that 2 applies to the entire ion. Okay, everything inside the parentheses. This must count, this 2 must go towards both the chlorine and the oxygen. It's 2 chlorines and 2 oxygens. Really, it's not 2 chlorines and 2 oxygens, it's 2 ClO ions. All right, so magnesium hypochlorite is MgClO2 with parentheses around the ClO. And again, we're going to do lots of examples of these, so don't, have a panic attack just yet. All right, look at that. How convenient. Examples of these. Let's try them. I feel like I should talk like a cyborg if I'm going to call myself Cyborg Piero, but I can't do that. All right, so barium sulfite. You all have your polyatomic chart. Honors for right now, I'm going to tell you what sulfite is. Sulfate and phosphate are 2 that you are going to have to memorize, and we're going to get to that very shortly. So for now, for honors, I'm going to tell you, all right, I'm going to write it next to it. Sulfite is SO3 with a -2 charge. Regular classes, you have sulfite on your polyatomic chart, okay? It's right there. SO3 with a -2 charge. Just what I wrote. SO3. Remember, the SO3 is your ion. Keep that together. The -2 is your charge. All right, so just so you know what that is. All right, so if we're going to give the formula, I'm going to draw an arrow. Just do exactly what we did when we did this before Christmas, okay? Just because there's more than 1 element there doesn't mean you should treat it any differently. We do all the same thing. So, barium. This is going to be super fun if you actually answer me and I can't hear you, but I'm going to give you a chance to answer. It's going to be like Dora or Blue's Clues when I ask you something and you're just talking to a TV and I pretend I can hear you. So that's what we're going to do. So, barium. We know barium's Ba. What charge does barium have? hopefully you said a positive 2, right? Plus 2. Sulfite, I already told you, or you looked it up if it's on your chart, is an SO3 with a minus 2, right? So don't make this more complicated than it needs to be. Do exactly what we did before Christmas. So we are going to pretend like the charges aren't there. Do not mess with this 3. I'm telling you now. Don't touch that 3. Leave it where it is. You've never done anything but cross charges. Keep doing that. Don't cross over the 3. Leave it alone. Leave it. Leave it alone. Don't touch it. Leave it alone. 2 and 2. That's what we're crossing over. Hopefully you're saying right now, but Miss Vero, they're both 2s, which means they're going to cancel each other out. And I would say, oh my gosh, you guys are so smart. I can't even handle it anymore. That's exactly what's going to happen. The rules don't change. Remember, if we were to cross these, we would end up with BA2 and then SO32. But we know that when they are the same number, they simplify. So all you're doing, again, no different at all than what we did when they were just single elements. When they cancel, you just put them together. BaSO3. Barium sulfite. Notice the 3 never went anywhere. It stayed right where it is. Don't touch it. Don't do it. Don't. All right, next one. Calcium phosphate. So we know calcium is Ca. And what charge does calcium have? You're all wonderfully correct because I taught you so well before we left. I'm just kidding, obviously. You know I'm just kidding. I only taught some of you really well before we left. Calcium's a +2. Phosphate, for regular classes, phosphate is way down here. It is PO4 with a -3 charge. Honors, I'm just going to write it for you for now. We're going to talk about how to memorize it in a few minutes. So, PO4 with a -3 charge. PO4, -3 charge. And I am actually going to draw a line separating these just so you don't get them confused. Alright, so Ca +2, PO4 -3. Exactly what we did before. Pretend the charges, the signs are not there, okay? It's just a 2 and a 3. The 3 will cross over to the calcium. The 2 will cross over to the phosphate, to the PO4. Do 2 and 3 simplify? No, you're exactly right. They don't simplify because they can't cancel each other out. One doesn't go into the other, so we just leave them the way they are. They don't simplify. So it ends up being Ca3, and then I'm gonna write this so it looks kind of spaced out, but there's a reason for it. PO4 2. So, what's the problem that you see? Miss Vero, I see that looks like there's 42 oxygen. Wow, you guys are, I can't even, so smart. You're so smart. We're so lucky to have you on this planet. You're right, this looks like it is 1 phosphorus and then 42 oxygen, and clearly we know that's not the case. That is not what just happened, not the reaction that happened. Remember, we need this 2 to apply to the entire phosphate ion. Okay, it has to apply to the whole thing. So if you go back to your steps, that extra step at the bottom, it says put parentheses around the polyatomic ion if you end with more than 1. Well, look at this. We've ended with 2 phosphate ions. So in order to fix this problem so it doesn't look like it's 42 oxygen, you want to put parentheses around the entire PO4. So now it is Ca3, PO4, 2. 3 calciums, 2 phosphates. That's no different than what we did before break. It's just this is a little bit of a bigger ion now, so it looks a little more confusing. It's not any different. All right, 3 calciums, 2 phosphates, Ca3PO42. Hopefully you're still with me. Opposite way, as always, this is the easier way to do this. All right, it's always going to be, it's never not going to be the easier way. So this shouldn't take quite as long for you to do. We know this is AlNO3,3. Your job, remember, your only job is to figure out which 2 ions are being put together. No prefixes, these are ionic, remember, there's no prefixes in ionic compounds, you just figure out which 2 ions they are, put them together. So we know Al, hopefully we know Al is aluminum, or aluminium if you are in 3rd period or 5th period, because you guys always say it over and over, especially Harry F. Lanigan. So we know it's aluminum, and then you just need to figure out what NO3 is, right? Because remember, this 3 is not really part of the ion. The 3 crossed over from the aluminum. So your job is just to figure out, well, what is NO3? What is that polyatomic ion inside the parentheses? So again, honors, you will have had these memorized at that point. Regular, oops, sorry, wrong chart. Regular, you can look yours up, unless you're choosing to memorize, which again, you already know. If you want to go into the medical field, it's something I strongly recommend. NO3, right here, with a -1 charge, is nitrate. Okay, NO3 -1 charge is nitrate. So the NO3 is really what we care about. We know the charge isn't going to be written in this compound because it was already crossed over. So you just want to find out what NO3 is. NO3 is nitrate. So this is simply aluminum nitrate. Done. We move on to the next one. What is Ni? Hopefully you said nickel. Now, what do you know about nickel? I really hope you guys are just sitting in dead silence listening to me talk and nobody's answering, because I hope I'm making this very awkward for you. That's my intent. So nickel, we know. Nickel is a transition metal. And what do you know about transition metals? You are right. I'm sure you're all right. That you need a Roman numeral if this is a transition metal that forms more than 1 charge. So, if you were to get out your trusty sorry, I'm trying to reach for it and hold this there at the same time. If you were to get out your transition metal chart and look up nickel, we know nickel is here, and we know nickel can form either a +2 or a +3. It is your job to figure out which one that was, just like it was your job before when there were only monatomic ions. It's your job to figure it out when it's polyatomic as well. So nickel, we know it's nickel, but we can't just say nickel because we need to describe whether it's had a +2 or a +3 charge before it was crossed. So how do we do that? This should not be new. We know that this 2 right here was crossed over from the nickel, and this 1 that we don't write was crossed over from the HCO3. So the only thing you need to check is to make sure these weren't simplified in any case, okay, or in any way before they were written. So just look up HCO3. This is on both charts. It's not one I'm requiring you to memorize. And HCO3 is right here, and it is hydrogen carbonate or bicarbonate. I like to call it bicarbonate because it's less writing. You're going to probably do that too because you all don't like to write long names just like I don't. So bicarbonate, HCO3, and notice it has a -1 charge, which means it had a -1 charge here as well. It wasn't simplified at all. So it means that this originally had a -1, which means this had to be nickel with a +2 charge. So this is nickel 2. All right, so we know this is nickel 2, and we just looked this up. That is bicarbonate. So that is nickel 2 bicarbonate. Nickel 2 bicarbonate. And that's it. All right. Not any different than monatomic. It's just they are a little bit bigger. They look a little scarier because there's more elements involved, but it's still the same idea. 2 ions, cross over the charges, simplify if necessary. Nothing new, just bigger elements. All right, so I'm going to put these up. We'll have the sub pause, and then he will unpause it, and I will have the answers up for you. All right. Strontium chloride, I'm going to go through these fairly quickly because you should already at least have answers for them. Make sure you got them right. But so strontium chloride, we know strontium's SR, positive 2. If you looked up chlorite on your chart, and again, honors, I know you're struggling with me right now because I haven't told you how to memorize these yet. But chlorite is ClO2 with a -1 charge. All right, hopefully you guys somehow figured that out. Maybe you looked at the other chart. Hopefully you were resourceful in figuring that out. So strontium's SR positive 2, chloride is ClO2 with a -1. So 2 and 1, we know those aren't going to cancel each other out anyway. Ignore the charges, cross over the numbers. So the 1 goes to the strontium, the 2 goes to the chlorite. I'm going to zoom in on this a little so you can see a little better. So when you rewrite this, we know that means we needed 1 strontium and 2 chlorites. So that means I would put a 2 here, and again, notice the issue. This should not look like it's 22 oxygen, so what are we missing? Again, I hope somebody's answering me. I'm going to assume you are. You are correct if you said we're missing parentheses. Put parentheses around it. That way it makes it known that it's 2 chlorite ions, that it's not 22 oxygen and 1 chlorine. Good. Next one, copper 1 chromate. So copper 1, hopefully I'm not blowing your mind, copper with a +1. Chromate is, if you looked it up, regular, and honors, hopefully you were resourceful and figured it out from the regular chart since I haven't taught you how to memorize them yet. Chromate is CrO4 with a -2 charge. So really this isn't any different from the one we just did. The 1 and 2 are not going to cancel out. Ignore the charges. The 1 goes to the chromate, the 2 goes to the copper. So when you rewrite this, you have Cu2, and then we know it would be CrO4 Oh, I'm so sorry. We know it would be CrO4, and there's 1 of them, but we don't have to write the 1, which means we don't need parentheses around it because there's no numbers to separate. We know if we just write CrO4, it's telling us there's 1. Okay, notice that doesn't simplify because this 4 was already there. It wasn't a charge. You only simplify charges, not the number that was already there. So copper 1 chromate is Cu2CrO4. Hopefully that's what you got. Down here, just put the 2 together. We know K is potassium. Sorry, left-handed is always going to make this more difficult. And ASO4, if you looked it up, is arsenate. Arsenate. That's it. Just put them together, right? Remember, we know this 3 doesn't matter because it's just the crossover from the potassium, and we looked up ASO4, arsenate. VPO4. So we know V, well, I know V, maybe you know V at this point, is vanadium. And hopefully you're already thinking, oh, vanadium, that doesn't sound familiar. It's probably a transition metal, and that would mean Roman numerals. You need to figure out which vanadium was used here. Use what you know about phosphate to figure out what you need to know about vanadium. So if we look at phosphate, or PO4, okay, you'd have to find this. If, for now anyway, honors, you'll have them memorized. PO4 is phosphate. Okay, PO4 is phosphate. So you know this, we're going to call this phosphate. Which if you want to, you could write that now just so you know, you don't forget what it's called. So it's vanadium phosphate. We just need to figure out which number vanadium it is, which charge vanadium had in this. Well, if you look, phosphate has a -3 charge, right? So stick with me. If phosphate had a -3 charge, what charge did vanadium have to have in order for you to end up with 1 vanadium and 1 phosphate? I know this actually could be a little challenging, but just think about it. There's no 3 written here, which means it canceled out. So the only answer, okay, the only 2 charges that would work in order to get this formula is that if vanadium had been a +3, since phosphate is a -3. So this right here is telling you we used vanadium 3 in order to get that formula. All right, vanadium 3 phosphate. Hopefully that's okay. I wish I could ask you if you had any questions, but I can't hear you anyway, so I can't ask you that. Right, but I'm going to assume, again, with a lot of practice, you guys will be fine. If you have questions, you can ask Mr. Perkins, see if he can help. If not, you are more than welcome to go talk to Mr. Fierro, and he will be more than happy to help you guys as well. All right? All right, I'm going to have you guys pause this. I'm telling you, write every word of this down. This is going to blow your mind once you see how this sentence works. It sounds absolutely ridiculous. Nick the camel ate a clam, crepes, and bran for supper in Phoenix, and then took an aspirin. I swear I'm not on crazy pills. This sentence is going to help you. So pause this for a second, write this stuff down, and I'm going to show you how this works, okay? All right. So we have this ridiculous sentence about Nick the camel. And in all reality, Nick the camel doesn't matter even one tiny little bit. Okay, it doesn't matter that it's about a camel named Nick. What you care about are those words that are capitalized and have the first letter or 2 letters underlined. So notice, in Nick, it's the N. So I'll just keep going. In camel, it's the C. In clam, it is the CL. In crepes, it is the CR. And obviously, you can go on from there. And then we want to also just make note that 8 is underlined. So on the polyatomic ions chart, you have 8 polyatomic ions and ite, ones that end in 8 and ones that end in ite. All right, and a quick example I'll show you just down here. So we have 2 polyatomic ions that exist are nitrate and nitrite. Both exist. And there's an easy way to memorize both, okay? And we're going to be able to do this for every single element that's in this sentence. So nitrogen, so nitrate, nitrite. Carbon, only carbonate exists, so that'll help. Chlorate, chlorite. Chromate, bromate. Sulfate, sulfite. Phosphate, phosphite. And then arsenate, because arsenic is AS. All right, you can use the sentence to memorize all of them. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 polyatomic ions from this ridiculous Nick the camel sentence you can memorize. All right, so back to down here. Notice for most of them, there is an 8 and an ite polyatomic ion. Nitrate, nitrite. Again, I just listed those. It's the endings you want to look at. So 8 is underlined in this sentence because these specific words are going to help you remember the 8 polyatomic ion. So Nick is going to help you remember nitrate, carbonate, chlorate, chromate, bromate, sulfate, phosphate, and arsenate. It's not that you can't use this to get to the ite ions, but these words specifically refer to the 8. That's why 8 is underlined. All right, so how this ridiculous sentence works. So if I ask you, what is nitrate? Now, obviously I know regular, you can just look this up, but again, I'm strongly suggesting that if you want to go into the medical field that you memorize these. And I'm just gonna slide this paper up. No, I'm not gonna slide this paper up at all because I'm gonna knock the camera over. So we'll do, oh, that's not gonna work either. Okay, hold on, stand by. If I knock the camera over, you'll understand because it's me. And I do stupid things all the time. Okay, sliding up. Now you can't see anything. Slide that back down. Hopefully you can see that. Good. All right, so how this works. So let's say I want to know what nitrate is. What is the polyatomic ion nitrate? All right, again, at regular you can look it up. Honors, you don't have that luxury. You have to memorize them. So we're going to use the word Nic. Okay, this sentence is much easier to memorize than memorizing 12 polyatomic ions. You don't have to memorize a sentence, just remember the words in the sentence. So we've got Nic. So I'm going to go ahead and write Nic over here. N-I-C-K, Nic. So the first letter or letters, okay, the ones that are underlined in the sentence, tell you what element it is we're talking about. So obviously we know if we're trying to find nitrate, we would use Nic. So we know that it's N. All right, one other thing to make note of is that all of the 8s and ites, all are that element, okay, nitrogen, carbon, chlorine, okay, going on, are all that element plus a number of oxygen. Okay, ites and 8s all have oxygens attached. Okay, you might want to make a note of that somewhere. Okay, 8 and ite ions all have oxygen, I just made an O to save room, attached. So the tricky part is figuring out how many oxygen are attached to each one. That's where this sentence comes in. All right, so the N in Nic is telling you that it's referring to nitrate or to nitrogen. That nitrogen is the element that you are focusing on. So nitrate, we know we're going to use Nic. We know it's N, and we know it's O something, right? It's a number of oxygen. That's what you need to figure out. So go ahead and look at the rest of these rules. So step number 2, the number of consonants. Now, I know it's been a while since elementary school when you learned consonants and vowels. The best definition I can tell you for consonants are not vowels, okay? You know your vowels are A, E, I, O, U. None of this sometimes Y and W garbage, okay? A, E, I, O, and U. A, E, I, O, U. Those are the original vowels, okay? Those are the ones we're working with. Consonants are every letter that are not those. I don't know if that's the definition in the dictionary, but that's my definition. Consonants are not vowels. So anything that's not a vowel is a consonant. So look, number of consonants in your word tell you the number of oxygen. So go and count the number of consonants in the word Nic. You've got the N, the C, and the K. 3. The number of consonants tells you the number of oxygens that are attached. So nitrate is NO3. Hopefully so far so good. The number of vowels tell you the negative charge. Well, there is only one vowel in Nic, so that means nitrate is -1. So just by using the word Nic and these few simple rules, you know now nitrate, instead of looking it up, you can do this, especially honors, you can't look it up, so you don't have the option. NO3 minus 1. Right, NO3 minus 1. So then what about nitrite, right? Because I said the sentence only applies to the 8s, but you can use it to remember the ites as well. So if you look at the 4th step, it's telling you 8 is underlined because all of these are the 8 polyatomic ions. All of these words from the sentence represent the 8. Ite ions will have one less oxygen if they exist. And I'm not going to ask you which ones exist. We'll just never refer to them if they don't exist. So nitrite, same idea. Okay, you could see, well, okay, I know Nic is for nitrate, so nitrate is NO3. That means nitrite must be NO2. One less oxygen. All right, so nitrate is just NO2, same charge, -1 charge. Hopefully you are with me. Okay, so number of consonants tells you the number of oxygens. Number of vowels tells you the negative charge. It's always a negative charge because almost all of our polyatomic ions are negative. So this is always negative charge, which is why I had you write that down right there. You can pause it if you need to, but we're going to go ahead and do, we're going to fill in this chart right here. So regular, you probably don't have to write this. Honors, I'm going to have you guys pause it And you can quickly kind of jot this chart down, and we're going to fill this in. I know asking you to quickly jot this down is a lot, but go ahead and make this real quick, and we'll fill these in by using the sentence. So pause it, go ahead and do that. Regular, you guys don't have to pause it, but you should still pay attention. All right, so we already did nitrogen, right? We know the nitrogen is going to come from the word Nick. We know the sentence gives us the eights, and then the ites just have one less oxygen. So we're not going to waste time doing this again. We know it's NO3 because of the 3 consonants, minus 1 because of the 1 vowel. We know ite is 1 less oxygen, so NO2. Okay, so carbon, looking at camel, right? We know, obviously, carbonate, it's going to have a C in it, and it's going to have some number of oxygen in it. So look at camel. How many consonants? 1, 2, 3. And how many vowels? 1, 2. Carbonate is CO3 minus 2. Carbonate does not exist. I know even in the realm of Star Worlds, that's great. Star Wars, Star Wars, I know carbonite is a thing. It's not here on planet Earth, so it doesn't exist. Chlorine, so we know we're going to use clam. Notice it's clam, 1 clam. Apparently Nick the camel wasn't that hungry because he only ate 1 clam. If you put an S on this, it's not going to be right. Make sure it's clam. So we know it's ClO. How many oxygen? 1, 2, 3. Charge, minus 1. So then we know chlorite, which does exist, is ClO2, minus 1. Chromium, so we know chromate, we know chromium is Cr, some number of oxygen. How many consonants in crepes? It is crepes, it's not crepes or creepies. Some of you don't know what crepes are. They're like flat pastries from France. They're delightful. But it's pronounced crepes, not creepies. It would be awesome if they were pronounced creepies, but they're not. They're pronounced crepes. It is 1, 2, 3, 4. So to CrO4 minus 2, because there's 2 vowels. And chromite is not a thing. So we know bromate is going to be BRO. Use bran. 1, 2, 3. Minus 1 because of the 1 vowel. Sorry, I'm not paying attention when I shift the paper. Sulfate, use supper. S, P, P, and R, that's 4. And then the U and the E tells us it's minus 2. So then what's sulfite? It's just 1 less oxygen, SO3, minus 2. Phosphorus, PO. Phoenix. Make sure you spell Phoenix right. The most common problem is people put PHEO instead of PHOE. That's honestly not going to matter. I'm not telling you to spell words wrong, but if you can't remember how to spell it, it's okay. It's OE instead of EO, but that won't make a difference if you flip the vowels. It's still the same number of vowels and consonants. So in Phoenix, we've got 1, 2, 3, 4 consonants and 1, 2, 3 vowels. PO4 minus 3. So then what's phosphite? Correct. PO3. I'm assuming somebody answered. I hope they did. Arsenate. So it's AS, even though I know it starts with AR. Arsenic starts with AR, but its symbol is AS, which is why we have aspirin. Aspirin you have to spell correctly. I spelled it wrong the first time I did this, and it doesn't work if you spell it wrong. So it's ASPIRIN. There are 2 I's. ASPIRIN. So count the consonants. A is a vowel. I don't know why, but every year people count the A as a consonant. I assume because it's capitalized. That doesn't change it to a consonant. It's still a vowel. So count the consonants. That's S, P, R, and N. ASO4. Now we count A as a vowel. 1, 2, 3. Minus 3. If I went through this too quickly, you guys have this on Edline. You can go back and watch it. And then the Do Now Tomorrow is about this as well. Okay, so I hope this helped. If you have questions, please talk to Mr. Fierro. Or like I said, hopefully Mr. Perkins is hanging in there. And you can maybe ask him a couple of questions as well. I do recommend you might want to go back and watch this again if you are a little bit confused, but we're going to keep working with these. This isn't the only time you're learning them. You're going to use these until June. But it's no different. It's still 2 ions. It's just these ones are bigger. And honors, you have some memorizing to do. But use the sentence. I think the sentence will be most helpful. All right. Miss you guys, and I hope that you guys are doing well. See you later.